Here's my Lab 5 program. This program will allow the robot to travel in a right triangle using coders. At each turn, the robot will turn in place. And for the right triangle, the beta angle I have is 38. The alpha angle I have is 52. Side A measurements was 100 centimeters, which was given. Side B was 78.13 centimeters, and the hypotenuse side C is 126.9 centimeters. Here we include the Romy library and its classes. Here lies all the magic numbers, the wheel diameter, wheelbase, the 90-degree turn, the beta angle turn, which is 142. How I computed that is taking 180 and subtracting from the beta angle. Same goes for the alpha angle, taking 180 degrees and subtracting the alpha angle from 180. The count per rev, which was given, the A distance, C distance, B distance, left motor speed, right motor speed when moving forward. This is the left motor speed for turning, right motor speed for turning, the stop motor, and a 2-second delay. Here has the count left variable to store the left encoder counts, the count right variables to store the right encoder count, number of pulses variable to store the number of pulses needed to travel a certain distance, T num pulses used to store the pulse needed to turn in place. So to start this program, button A will need to be pressed. In our loop, we will call the drive straight function, which will drive the robot on side A forward. Once it reaches destination, it will stop. Turn robot function will be called. This is the function to turn the robot in place. And it will be turning using the beta angle. Once that turn is complete, it will stop. Drive straight function will be called to drive the robot down side C. There it will stop, turn at angle alpha, drive straight on side B. Once it stops, it will turn on that 90-degree to its starting position, and the wait for button A function will be called to start the program again. So here is the drive straight function with its 3 parameters: the left motor speed, right motor speed, and the distance. Before starting the function, a 2-second delay is called. Here we will reset both encoders to 0. And the next line we will compute the number of pulses needed to travel the certain distance given here in the parameter. A while loop is created so that it will loop until the pulse count is met. Motor speeds are set to both motors, and then left count and right count will be stored with the encoder count. An if statement is created to check the pulse count between both encoders, and once that's complete, the motor will stop. Below that function, we have the turn robot function, which will allow the robot to turn in place. It has a parameter of the left motor speed, right motor speed, and a turn degree. Again, before this function begins, there is a 2-second delay. Resets both encoders to 0, and we'll compute the number of pulses needed to turn in place. And similar to the drive straight function, we'll use a while loop to loop until the pulse count is met. um, motor motor speeds are set to both motors. And the left and count count left and count right variables to store the encoder counts for each encoder, and then the if statements to check the post count. And once that's complete, the left the motors will stop. Down here we have the functions to compute the number of posts traveled per distance. Here it has this parameter, the wheel diameter, the count per rev, and the distance. On this line, we compute the number, to compute the wheel rev per pulse. Once we got that information, we'll take the distance and divide it by that wheel rev per pulse and return that information. The last function is the count for turn. It determines the number of pulses for when the robot's turning in place with its parameters here. The wheel diameter, the count per rev, the wheelbase, and the pretty much the angle. So the first line we compute the wheel rev per pulse. Using that information, we'll compute the number of pulses to turn in place, and we'll return that information. From there, we will upload the program to my robot. Okay. Done uploading. We'll go test. Turn the robot on. Let's see. Straight. Okay, straight. Measuring tool. About 3 centimeters to the left and about half a centimeters forward of the starting position.